Hello friends. In our today's session, we are going to discuss about Newton's laws of motion. So now the first law of Newton's motion here is, let's say, let's discuss about the first law. So according to the first law of the Newton, it's like if a body is in a state of, let me write it for you, if a body is in state of rest or of motion or in a state of uniform motion or in a state of uniform motion, then it will remain in the same state, then it will remain in the same state unless an external force is applied on it. Okay, so let's say there are a lot of examples for the same. It's like, let's say if you have a box over here which is residing on some table. So this box will remain in its state of rest unless and until that if you apply some force on this and it will start moving. So if you apply some force in some random direction, so that box will start moving in that given direction. Or let's say if somebody is moving, it's something like that way. If it is moving in this direction, and you apply a force in the opposite direction, so this body will gradually come to rest. Right. So this is what your first law of motion. That means if a body is in motion, it will remain in motion. If a body is at rest, it will remain at rest. Okay. So this is the first law of motion. And if we talk about a qualitative discussion for the same, we have to first of all define two different terms. These are inertia. Let me write it. The first term that we are going to define over here is inertia. Okay. And the second one is force. Definition of force and definition of inertia. So, first of all, it's something about inertia. Let me write a statement for the same. Inertia is nothing but just the property by virtue of which an object tends to retain its state of rest or of motion. It's just a property by virtue of which the body retains its state of the body retains its state of rest or that of motion. Okay, that means like it's just an internal property of a body, so by virtue of which it will either remain at rest or will remain in the motion. So that property by virtue of which this activity takes place is called as inertia. Okay, in fact it is the inherent property of a body Now, the thing is like if we move ahead and if we try to define force, so force is that external cause which tends to change the state of rest or the state of motion of an object, right? It's nothing but just the external cause. Let me write it for you. External cause which tends to change the state of rest or state of motion of an object. State of motion of an object. Okay, it's just an external effect, you can say. So, like if some body is at rest and you apply a force on this, obviously the state of the body will change. It will start moving towards the direction of force. And similarly, if the body is in motion and if you apply the force over the same, this will come into the rest position. Okay. So we have a lot of examples, which confirm this first law of motion. Like when a train suddenly starts moving forward, the passenger standing in the compartment tends to fail backward. Right? The reason is that because the lower part of the passenger's body is in close contact with the train. Right? So as the train starts moving, the lower part shares the motion shares the motion at once, but the upper part, due to inertia of rest, cannot share the motion simultaneously. And so, it tends to remain at the same place. And consequently, the lower part of the body moves ahead and the upper part is left behind. And obviously, this leads to the backward fall of passengers. Okay. Similarly, like on hanging a carpet, when a hanging carpet is beaten by a stick, the dust particles start falling out of it. Why? Because the part of carpet where the stick strikes comes in motion at once, while the dust particles settled on its fur remain in a position of rest due to inertia. So thus the part of a carpet moves ahead with the stick, leaving behind the dust particles which fall down due to Earth's pull. Right. So these are a few examples like we can discuss here, like how this how practically we can realize this Newton's first law of motion. Now let us discuss about the Newton's second law of the motion. Right. So the thing is like let's move ahead. Under the Newton's second law of motion, we are going to talk about some of the relative terms, and one of the relative term that we are going to discuss over here is momentum. Momentum. Okay. Now what is this momentum? Momentum is of a body is actually the product of mass of the body and velocity of the body. Okay. Here v signifies velocity of the body and m signifies mass of the body, right? So there are a lot of examples where you can practically experience this momentum setup here. Now I hope all of you have played cricket at least once in your lifetime, and when a fast ball comes and you can catch it at a boundary as well. So you know that the speed of the ball is extremely high, right? But the mass is very small. So you can directly catch it and it won't cause any harm to your hands, right? In a similar way, like if there is a truck, right, and it is coming towards you, and if it hits you, even if it is at a very low speed, even then it hurts a lot. Why? Because its mass is very high, right? So the thing is, like, no doubt the velocity, maybe the velocity remain the same, but if the mass is different, obviously this will increase the momentum of the truck as compared to the cricket ball, right? So this is something called as your momentum. Now, as per the this second law of this Newton, the statement includes, like, this rate of change of momentum of a body is directly proportional to the force applied on it, and a change in momentum takes place in the direction in which force is applied. Let me write it for you. This is second law, right? So rate of change of momentum is directly proportional to the force applied on it, to the force applied on it. Okay, so this is the second law of Newton's second law of motion. Now, if we try to figure it out, let's say this rate of change of momentum, right? Rate of change of momentum, how you can find it out? It's like, let's say, delta p upon delta t, right? Now what is this delta p and delta t? Delta p is actually the change in momentum. Like, let's say we have final momentum minus initial momentum, we have final time minus we have initial time, right? Let's say some body is moving and it is some at some position at some instance of time. We can call it at the initial position, and after some time it reaches to some another destination, and we can call it as final position, right? So similarly, let's say pf is final momentum, right? Pi is initial momentum. You don't need to write it in your exam, because I'm just trying to explain it to you in a little bit simpler wordings actually. Similarly, T final is final time, right? And T initial is initial time. Okay, so now if we write it like this once again, let's say delta p and delta t, this can be written as m delta v upon delta t, right? Now delta is again symbolizing like v final minus v initial upon t final minus t initial. Fine. Now what is this delta v upon delta t actually? Delta v upon delta t is nothing but the rate of change of velocity. And I'm sure you know very well that what is the rate of change of velocity. Rate of change of velocity is always equals to acceleration, right? So finally what we get? We get force is actually equals to mass into acceleration, right? The force applied over the body of mass m is actually equals to the mass of the body along with the product with the this acceleration produced within the body itself. Okay, now let's discuss a couple of examples. Like while catching a ball, good. Like to say that we have got an example from cricket itself. Like while catching a ball, the cricketer withdraws his hand along with the ball. Right? Why? Because let's say if velocity of the ball is very high, obviously. So if if you just directly catch your catch a ball without moving your hand or without withdrawing your hand, it will hurt a lot, right? But if you move your hand in the direction of this ball itself, so you won't get much injury, right? I hope you have experienced it. So that's only because like it is if the your rate of change of velocity and the this is the rate of change of momentum, because of which if you move your hand in the direction of the applied force, you will nullify the actual impact of that particular ball on your hand, right? In the similar manner, you might have seen that during the athletic long jumps especially, or long jumps or high jumps, what happens, like athletes used to jump on the sand, or they used to jump on kind of mattresses actually. Why so? Because if they jump on the land or cemented land, what will happen? That cemented land will not move according to as per the direction of their body, right? So that will hurt those athletes a lot, right? Similar examples you might have seen, like if you drop a glass on this floor, it will break down, right? But if you drop the same glass on a sand, it won't break down. Why? Because even if the glass falls on the sand moves little bit downwards, right? So that will move in the direction of motion. So that's why it won't break actually, right? The force will not make much impact on that particular glass. So this is in accordance with the second law of motion, right? Now similarly, let's discuss about the third law of motion. Newton's third law, quite very famous actually. And according to Newton's third law, Newton's third law. Newton's third law is to every action there is equal and opposite reaction, right? It's a similar way, like if you apply some force on a wall, the wall applies equal and opposite force on you, right? You might have seen that, like if you fire from a gun, right, the bullet moves in the forward direction, and the gun also recoils and moves in the backward direction, right? Why so? Because of equal and opposite reaction. But the thing is, like, it's a very common question. Like, bullet moves at a very fast rate, but a gun moves a little bit slower. You can handle it very easily, right? Why so? Because of the concept of conservation, conservation of momentum, conservation of momentum. What is this conservation of momentum? Conservation of momentum is like the momentum produced by the bullet, let's say m1v1, will be same as the momentum produced by the gun. And you know that the mass of bullet is quite less than the mass of gun, very less in fact, as compared to the mass of gun. So that's why we receive a lesser velocity. The gun will recoil with much less velocity as compared to the bullet, right? So that is the reason. And another thing is, like, we have different sets of cases, like you can say like motion of a boat moving away from the shore. So, like when a boatman wants to move the boat away from the shore, He pushes the shore by a bamboo or with his oar. The shore pushes the boatman away with an equal and opposite force. Right? So these are a few details about Newton's laws of motion. I hope the concept is clear to all of you, and in case if you have any doubt or any question, feel free to let me know on that. Okay? Have a nice time ahead and take a very good care of yourself. Bye bye.